Okay, well, if you made it through the first two examples, then you're ready for the last example, which is maybe the most challenging. So lots of things going on in this problem. So we have the integral of x to the sixth minus 5, and then all divided by the square root of x. Okay, kind of like when we did derivatives, anytime that we have a single term in the denominator, which is what we have right here, we have square root of x in the denominator, we're going to split through the numerator so that we can simplify the problem before using the power rule. And if you'll notice, we haven't talked about any kind of quotient rule for antiderivatives, and that's because one really doesn't exist. There's not really a quotient rule for antiderivatives the way there is a quotient rule for derivatives. So anytime we see this type of a problem, the first thing that we have to do is split through the numerator. So I'm going to write this as the integral of x to the sixth. And then also remember from example 2 and what we talked about before you started the guided practice, anytime we have the square root of x, we cannot do anything with that notation. So we have to change it to x to the 1/2, and then I'm going to put the dx. Okay, and then I'm going to put a minus, and I'm going to move that 5 out from the integral sign, and this is going to end up being the integral of 1 over x to the half. And then I'll try to fit my dx there at the end of the screen. Okay, so that's the first thing that we need to do is split through the numerator. So that's what I've done, and I've also split into two different integrals for this particular problem. Now what I'm going to do is clean it up. So I'm not really using the power rule yet. I'm just simplifying things so that I can use the power rule. Okay, remember that when I divide x to the sixth minus, x to the sixth divided by x to the 1/2, I'm subtracting exponents. Okay, so I'm going to have x to the 6 minus 1/2, which is going to give me 11 over 2 dx. Okay, so that right now is cleaned up. On the next step, I'll be able to use the power rule just fine. Okay, on the next part of the problem, I have minus 5 and then integral. And remember, anytime I have an x in the denominator, very similar to problem number 2 that you worked, I'm going to have to move that up to the numerator and change the sign of the exponent to a negative. Okay, so now we have the integral of x to the 11/2 dx minus 5 integral x to the negative 1/2 dx. And so now what we're able to do is use the power rule for antiderivatives. Okay, so I'm going to take x to the 11/2, I'm going to increase the exponent by 1, and if I increase 11/2 by 1, that's going to give me 13 over 2. Okay, the next step after I increase the exponent by 1 is to divide by the new exponent. And recall that if I divide by 13/2, that's really just me multiplying by the reciprocal, which is 2 over 13. Okay, so that particular term is going to look like that, 2x to the 13/2 over 13. Now, in the next problem, I'm going to do, or in the next part of the problem, I'm going to do the same thing. I'm going to increase the exponent by 1, okay, which is going to give me x to the positive 1/2, 1 over 2. And then if I divide by 1/2, that's the same thing as multiplying by the reciprocal of 1/2, which of course is 2. Okay, so I'm going to put the 2 right there back next to the 5, and so that in my next line I can clean that up and make it a 10. Okay, and then obviously we don't want to forget, hopefully at this point we feel very comfortable with putting the plus c at the end. That's our constant of integration. Okay, and so the final answer is just going to be me cleaning up the 5 times 2 there. So I have 2 over 13 x to the 13/2, and it's okay for me to write it like this, or I could write it all over 13 if I wanted to. It won't really make that big of a difference. This will be minus 10x to the 1/2 and then plus c, and that will be the final answer for the antiderivative. So hopefully you feel comfortable with this subject. Let me know if you have any questions, and sit tight. I'll let you know what we're going to do next.